Welcome to this, the third in a series of 5 videos about modelling ventilators. In this video we'll discuss modelling ventilator masks. In videos 1 and 2 we talked about rocking bed respirators, and in videos 4 and 5 we'll finish the last of the rocking bed respirators and show an ambu-bag ventilator device. The ventilator mask we'll talk about today comprises of a soft drinks bottle and a syringe joined by a few bespoke plastic elements. Let's give you a quick introduction. Here we have the end of a 2-litre carbonated drinks bottle that has been shaped to fit a typical face, and it fits both my face and Frances's face. And as Frances will attest, her face and my face are quite different. So given that it was easy to make it fit 2 different faces, one might imagine that it will fit a good number of other faces as well. Here we have the syringe, which is pneumatically powered to seal the valve, exhaust valve here, and elastically retracted to open the exhaust valve. Here we have a very crude inlet port which doesn't work very well. We have elastic to hold it to the person's head, and we have just two supports holding the syringe to the face mask, which allows it to float a little bit and hence helps the self-aligning characteristics of the valve against the valve seat. To hold the syringe to the bottle we have 2 C plates which clamp around the collar on the neck of the bottle, and so that the syringe can't pull away. Now let's look at each one of those points in turn. Here we have the carbonated bottle face mask. Now shaping this wasn't done easily. We started off with a long bottle and attempted to cut the correct face shape out of it, and when we finally achieved the correct face shape, then we just shortened it to make it a practical length. In fact, I still think this face mask is a little bit too long, and perhaps a 3-litre bottle would have created a better face mask. This inlet port, for what would be an inlet port here, has never been used. What this was originally was this exhaust port, and the syringe was located here, but it didn't work very well in that location because the material is too flexible. And so I decided to move the valve for the exhaust port to the nose of the bottle, where there's lots of solid structure to seal against. This rubber tube here is silicone rubber tube, which has just been split so that it can be slipped over the rim of the bottle to make the face seating better and to make it more comfortable, although it could certainly be more comfortable still. To enable the syringe to attach to the bottle, we had to make a collar to go around the collar on the top of the bottle, but that collar had to be split into 2 parts so it could slip either side of the collar on the bottle, and then bolts run through it to hold it in that location, screwed rod run through it to hold it in the appropriate location. Here we have 3 plastic elements that were fabricated to convert the syringe into a primitive valve. Here we have the valve seat and the attachments for the return elastic. Here we have the holder of the syringe, and here we have the rear end of the elastic attachments. So the valve shuts off and then opens, shuts off and then opens, shuts off and then opens. A little bit of string here just helps ensure that these elastic straps don't unclip from the ends of the arms. The rubber material on the face of the valve is simply a balloon stretched across the surface to improve the sealing quality when the valve is closed. Okay, let's see it demonstrated. Okay, there are obviously plenty of areas for potential improvement, but 4 I could find straight away would be: 1, looking at the possibility of using a 3-litre bottle rather than a 2-litre bottle here. 2, engineering an improved stroke working inlet port. 3, reducing the mass on the moving parts of the syringe, because every time that mass comes to a halt on the seat of the valve, it sends a vibration into the face of the wearer. And 4, looking at the possibility of working with 3 rather than 2 supports here to stiffen up the structure. However, that might compromise the quality of the seal achieved, so it might work better with 2, but it has been an experiment worth trying. Obviously, there are plenty of other areas as well. Francis and I have demonstrated here is a model. It's not a medical device, and nor is it a toy. Any actions undertaken as a result of viewing any part of this video are performed entirely at the viewers and their associates' own risk in every regard. We're working hard to complete the set of 5 videos about ventilators. The last 2 will undoubtedly be the best yet. So keep up the social distancing and check back soon. Bye for now.